In the vast green landscapes that feed our planet, a quiet crisis unfolds after every harvest. This is a banana plantation. For every bunch of fruit that makes it to our tables, the massive plant that grew it is left behind. Globally, this adds up to a staggering amount of waste. Well over 100 million metric tons of banana pseudostems are discarded every single year. Most of this is simply left to rot, releasing greenhouse gases. Or it's burned, polluting the air we breathe. It's an incredible scale of waste, a problem hidden in plain sight. Pause. Now, look at this. Clean, precisely engineered, and essential. A sanitary pad, a product relied on by billions, yet one that carries its own environmental price tag. What if these two, a wasted plant and an essential product, were part of the same story? What if the solution to a colossal waste problem was also the solution to a personal and environmental challenge? What if you could take this mountain of discarded stems and transform it into this vital product, not just sustainably, but on a massive industrial scale? This isn't a what if anymore. Inside a state-of-the-art megafactory, a quiet revolution is underway. This is the story of how high-tech engineering and radical sustainability are coming together to turn agricultural waste into a product of wonder. We're going inside to witness the incredible journey from a forgotten stalk in a field to a sterile, biodegradable sanitary pad that is changing everything. Chapter 1. The Dual Crises. To really get the genius of this operation, you first need to understand the two massive problems it's built to solve. First, there's the crisis of waste. The global banana industry generates an immense footprint of biological waste. After that single bunch of fruit is harvested, the entire plant, which can weigh up to 45 kilograms, has served its purpose in traditional farming. For decades, the options for dealing with it were pretty bad. Farmers could let the thick, watery stems decompose, slowly releasing methane, a greenhouse gas way more potent than CO2. Or, to clear the land, they'd burn them, sending smoke into the atmosphere. It was a lose-lose situation. At the exact same time, a second crisis has been unfolding in our homes and our landfills. The crisis of plastic-based menstrual products. The conventional disposable pad is a modern convenience, but it comes at a steep environmental cost. What most people don't realize is that an average pad is made of up to 90% plastic. The leak-proof back, the super absorbent polymers that lock in fluid, even the soft top layer, they're all derived from petroleum. Each pad is basically a single-use plastic product. Think about the numbers. A person might use between 10,000 and 12,000 disposable menstrual products in their lifetime. With billions of menstruating people on the planet, that creates a colossal amount of waste. And because they're plastic, these pads don't just disappear. A single sanitary pad can take 500 years or more to break down in a landfill. For centuries, they stick around, slowly shedding microplastics that contaminate our water, our soil, and even our food. And the issue goes even deeper. In many parts of the world, access to safe and affordable menstrual products is a huge challenge, something known as period poverty. In a country like India, for example, studies have shown that around 20% of women may not have the supplies they need for their period, an issue that impacts education, work, and health. Conventional pads, with their reliance on petroleum-based materials, are often just too expensive for millions. So here we are, stuck between two monumental problems: a mountain of agricultural waste on one side and a mountain of plastic hygiene waste on the other. Both are byproducts of modern life, and both are screaming for a smarter solution. This is the stage for our story. A story that asks, can we solve both problems with a single, elegant idea? Chapter 2. The genesis of an idea. Every great leap forward begins not with a machine, but with a question. In this case, Could the fibrous strength of the banana stem, the very thing that makes it so tough, be harnessed for something new? The answer is hidden inside the plant's biology. A banana stem isn't just pulp. It's a dense bundle of long, powerful cellulose fibers. For centuries, these fibers were used for things like textiles and paper, but their true potential was never unlocked on an industrial scale. The innovators behind this mega factory saw what everyone else was overlooking. They saw a raw material that wasn't just abundant, it was being treated as garbage. And more importantly, they realized its natural properties were perfect for solving the problems with conventional pads. Banana fiber is a natural superabsorbent. It can soak up and hold a remarkable amount of liquid. It's also incredibly strong, meaning it can be processed into a durable material that won't fall apart. And that's where the genius of the substitution clicks into place. For years, the go-to natural fiber for absorbency has been cotton. But cotton is a notoriously thirsty and demanding crop. Compared to banana fiber, which is literally an agricultural leftover, cotton requires immense resources. It takes way more water and fertilizer to produce a ton of cotton than it does to simply collect a ton of banana stems. By switching the raw material from a resource-hungry crop to an existing waste stream, the entire environmental equation gets flipped on its head. But an idea is one thing. Making it happen on a massive scale is a whole other beast. How do you turn a tough, wet plant stalk into a soft, sterile product that can compete with the most advanced pads on the market? This isn't a craft project. This requires a deep understanding of engineering and chemistry, all while meeting the highest standards of hygiene. The vision was to create a circular economy in action, a system where waste doesn't exist. In this factory's design, the banana stem is the main ingredient. The fibers become the pad's absorbent core. But what about the rest? The huge amount of water squeezed from the stems? The nutrient-rich pulp? That couldn't be wasted. It would be captured and repurposed. The water would be recycled back into the system, and the leftover organic material would be processed into fertilizer and returned to the very farms where the bananas were grown. This was the blueprint, a zero-waste facility where technology and nature work in perfect harmony. The challenge was immense, but the journey from that initial "what if" to a fully operational mega factory was one of relentless innovation. And it all begins in the field. Chapter 3. The journey begins. From field to factory. Our story kicks off not at the factory gate, but miles away in the heart of banana country. Here, among the rows of towering plants, the first step is taken. Once a heavy bunch of fruit is sliced from the plant, the pseudo-stem that supported it is done. In the past, this was the end of its story, a bulky piece of waste for farmers to clear. But now, it's an asset. This is the first ripple of change. Instead of being a problem, the stems are now a source of extra income for local farming communities. Collection teams, working with the factory, gather the freshly cut stems. This simple act injects new money into the rural economy, turning a waste product into a cash crop and creating local jobs. You can see the human benefit before the material even enters the factory. The scale of the operation quickly becomes clear as trucks, piled high with stems, make their way to the factory's receiving bay. The air is thick with the sweet, earthy smell of raw vegetation. This is where the transformation officially begins. Upon arrival, nothing is left to chance. Each truckload is weighed, logged, and sampled for quality. The stems have to be fresh and meet specific criteria to make it to the production line. This is the first of many quality control checks that define the entire operation. The first real processing step is a powerful one. The stems are loaded onto conveyors and sent into a high-pressure washing station. Here, powerful jets of recycled water blast away any soil, insects, or other gunk from the field. This is critical. The final product has to be medically sterile, and that starts with making sure the raw material is impeccably clean. After the wash, the glistening stems glide along another conveyor for sorting. Here, a mix of trained workers and sensor technology categorizes the stems by size and quality. Just like a chef picking the best ingredients, the system ensures that only the stems with the most long, strong cellulose fibers are sent to the main production line. Stems that don't make the cut aren't wasted. They're diverted to be made into compost and fertilizer. This whole intake process is a symphony of logistics designed for maximum efficiency and minimum waste. The humble banana stem has arrived, ready for its remarkable transformation. Chapter 4. The heart of the machine. Fiber extraction. We now enter the core of the factory, a huge hall filled with the hum and rhythm of custom machinery. This is where brute force engineering meets the finesse of material science. The goal here is simple: to free the valuable cellulose fibers locked inside the banana stems. It starts with surgical precision. The clean stems are fed into a machine where high-speed blades split them lengthwise. This isn't random shredding. It's a strategic move to open up the stem so the next stages can work more effectively. From there, the split stems move into a temperature-controlled steam chamber. A blast of hot steam sterilizes the material, killing any lingering microbes, and also softens the stem structure, beginning to break down the natural glues holding the fibers together. It's like a high-tech pressure cooker, perfectly prepping the material for what's next. And what's next is the most dramatic part: the rollers. The softened stems move into a series of massive roller presses. These heavy cylinders apply immense, calculated pressure, squeezing the stems with incredible force. As they're crushed, two things happen at once. First, a huge amount of nutrient-rich water is expelled and collected below, destined for the factory's water recycling and fertilizer units. Second, the pressure shatters the brittle pulp around the fibers, breaking them free. What comes out is a wet, tangled mass of raw fiber and pulp. This mixture is then fed into an industrial carding machine. Carding is a classic textile process, reimagined here. The machine uses rotating drums covered in fine metal teeth to comb the fibers, aligning them and separating the good, long fibers from any junk. The output is a uniform web of raw banana fiber, ready for the next phase. So far, the journey has been all mechanical. Now it enters the realm of controlled chemistry. The raw fiber is transferred into large, sealed tanks to be purified. The goal is to remove the last two things that would compromise softness and absorbency: lignin and hemicellulose. To do this, the fibers are gently boiled in a carefully prepared, alkaline solution. Crucially, this happens in a closed-loop system. The solution is reused, and any wastewater is treated on-site before being recycled. This ensures no harmful chemicals are released. The valuable sap and other organic stuff recovered here are again diverted to become liquid fertilizer, a perfect example of the factory's circular philosophy. After a thorough rinse, the purified fibers need to be dried. Some facilities spread them onto vast beds to dry naturally in the sun. Others use industrial drying chambers with warm, circulating air. Sensors monitor the moisture level in real time. Too much and the pulp is inconsistent. Too little and the fibers get brittle. The final step in this section is turning stringy fiber into fluffy pulp. The long, dried strands are fed into a pulverizing machine, often called a hammer mill. It uses mechanical force to break down and fluff up the fibers, transforming the coarse material into something that looks and feels like soft white cotton. This is the banana fiber pulp, the super-absorbent heart of the sanitary pad, now ready for assembly. Through a relentless sequence of cutting, steaming, crushing, and fluffing, a piece of agricultural waste has been re-engineered into a high-value, medical-grade material. Chapter 5. Assembly line. Alchemy, creating the pad. We now move from the raw processing area to the clean room environment of the assembly hall. The noise shifts from the heavy rumble of extraction to the high-speed whir of automated assembly lines. This is where all the pieces come together with incredible speed and precision. It all starts with the star ingredient, the fluffed banana fiber pulp. The pulp is fed into a hopper and then air laid onto a moving conveyor. Automated systems distribute it into a continuous flat mat of a precisely controlled thickness. This isn't just a random pile of fluff. Computer-controlled systems ensure the absorbent core has no weak spots. This is critical for performance, creating a multi-layered core that can absorb a remarkable amount of liquid, rivaling or even exceeding the capacity of many leading commercial brands that rely on synthetic polymers. As this absorbent core moves down the line, the layering begins. Spools of different materials above and below the conveyor feed their layers into the assembly at the perfect moment. First comes the top sheet, the layer that touches the skin. Here, it's not plastic. It's a soft, breathable, plant-based fabric, designed to be hypoallergenic. It's also designed to let liquid pass through it quickly into the core, keeping the surface feeling dry. At the same time, the back sheet is applied to the bottom. This is the leak-proof barrier. In a conventional pad, this is a sheet of plastic. Here, it's a specially designed biodegradable polymer, often made from cornstarch. It's waterproof, but it's designed to break down in a compost environment. Now we have a continuous, multi-layered sandwich of material moving at high speed. The next step is to seal it all together and give the pad its shape. This is done with two incredible pieces of technology. First, ultrasonic sealing. Instead of glue or heat, the factory uses high-frequency ultrasonic vibrations. Robotic heads target the edges of the pad, and the vibrations create a strong molecular bond between the layers. The process is clean, incredibly fast, and creates a secure seal without adding any extra materials. Immediately after, the strip passes under a laser cutter. A computer-guided laser beam flashes across the material, instantly cutting out the final pad shape, complete with wings. The laser is so precise that it also cauterizes the edges, preventing any fraying and creating a perfectly smooth finish. This combination is the peak of modern manufacturing. Ridiculously fast, exceptionally precise, and completely sterile. In a matter of seconds, a handful of fluffy pulp has been transformed into a complex, highly engineered product, ready for its final checks. Chapter 6. The Final Frontier: Sterilization and Packaging. The journey from a muddy field to a high-tech assembly line has been incredible, but it's not over yet. Before these pads can be sent out, they have to pass two final crucial stages: medical-grade sterilization and smart packaging. As the newly cut pads come off the line, they're automatically conveyed into a sterilization chamber. Here, any lingering microorganisms are eliminated. Some factories use UVC light, a powerful germicidal radiation that kills bacteria and viruses. Others may use a controlled gas sterilization process, common for medical equipment. Either way, the method is chosen to be totally effective while having zero impact on the natural materials. Quality control is woven through the entire process, but here is where the final, toughest checks happen. Automated systems pull sample pads from the line at regular intervals. In an on-site lab, vision systems check for any visual defects. Robotic rigs test absorption capacity and speed. Other machines pull and twist the pad to make sure it won't fall apart during use. Any batch that shows the slightest flaw is immediately rejected. Only the pads that pass these final tests are cleared for packaging. And once again, it's a marvel of automation. The sterile pads are fed into a machine that folds the wings with a speed and precision far beyond human capability. The commitment to sustainability continues right to the end. The individual wrappers aren't plastic. They're made from compostable films or paper. The folded pads are sealed, counted, and bundled into boxes made from recycled cardboard. The entire product, from its core to its box, is designed to return to the earth safely. The packaging often says it loud and proud, detailing the pad's biodegradable properties and its ability to decompose in months under the right compost conditions. A huge difference from the 500-year sentence of its plastic counterparts. With the final box sealed, the transformation is complete. What started as a discarded stock is now a clean, safe, and sustainable product, ready to be shipped. Chapter 7. Impact and the bigger picture. The final stage in the factory is a quiet ballet of logistics. Robotic systems stack the finished boxes onto pallets, which are then whisked away to a warehouse, ready for distribution. But the real impact of this place extends far beyond its walls. This factory isn't just making a product, it's manufacturing a better future. Let's step back and look at the full circle. First, the environmental impact is huge. By creating a market for banana stems, this factory helps solve a massive agricultural waste problem. Millions of tons of biomass are diverted from being burned or left to rot, preventing the release of huge amounts of greenhouse gases. On top of that, every single pad that leaves this factory replaces a plastic-based one. That means less dependency on fossil fuels and a real drop in the single-use plastic pollution choking our landfills and oceans. Then there's the social and economic impact, which is just as powerful. The whole supply chain is built to empower people. It starts with the farmers, who now have a new, steady income from something they used to throw away. That small shift can have a ripple effect, improving livelihoods in rural communities. Inside the factory, a deliberate choice is often made to hire women from local communities, offering not just a job, but skills training and economic freedom. And finally, there's the impact on health and dignity. By producing a high-quality, chemical-free product at a better price, the factory directly fights period poverty. These pads are free from the chlorine and dioxins found in some conventional products, offering a safer alternative. By making them more accessible, this operation helps ensure more people can manage their periods with safety, comfort, and dignity. This is the circular economy made real. It's a system where the banana stem provides fiber for pads, and the leftover plant matter becomes organic fertilizer, which goes back to the farmers to enrich the soil for the next harvest. It's a model that proves business can be a force for good, and that industrial production can be regenerative, not destructive. This factory is proof that the smartest innovations are often the ones that find extraordinary value in the ordinary, turning what we once saw as waste into a source of wonder. We've journeyed from a sun-drenched banana plantation through the roaring heart of a high-tech factory. A finished product that holds the potential to solve some of our biggest challenges. We've watched a discarded stem become a meticulously engineered sanitary pad. But this is more than just a how it's made story. It's a glimpse into the future of manufacturing, a future where sustainability isn't a buzzword, but a business model. It's a world where environmental responsibility and cutting-edge engineering work together. What was once agricultural waste is now the foundation of a life-changing product. What was once a source of pollution is now a source of income. And what was once a disposable plastic item is now a biodegradable tool of empowerment. From waste to wonder, from field to factory, this is more than just a sanitary pad. It's a blueprint for a cleaner, fairer world. It shows us that the solutions we need are often hiding in plain sight in the things we throw away. If you believe in the power of innovation to solve big challenges, share this video. Let's spread the word that incredible solutions can be found in the most unexpected places. And now we want to hear from you. What other forms of waste do you think we could transform with a little imagination? Let us know in the comments below. Thanks for watching,